All right, we're looking at lesson 2 for linear inequalities. In this lesson, we're going to continue to look at representing inequalities on number lines and how to go from inequality to words and vice versa. So keeping in mind the two different dots for your boundary points. Remember, if we have a closed dot, that's saying that our boundary point is, and it could just be equals, right? But includes some kind of equal, whereas if we have a boundary point that's open, it cannot have the equal sign along the bottom, okay? So it either be just a less than or a greater than. Okay, so, and we're going to try to get through these notes as best as we can without too many stoppages. We have a lot of announcements going on right now in the building, so hopefully we won't have too many distractions. Okay, so just kind of a review of what we did in lesson 1. It says, in Alberta, you must be at least 16 years of age to get a driver's license. Some of you will be getting those soon. That terrifies the life out of me. I will stop driving at that point, I think. So anyway, we're going to make a number line to represent the situation. So on that number line, let's put your ages. How about? So let's start at age of maybe 0, right? And I'm going to go up by 2 years because it's a lot of lines to make. And I can't even go up by 10. There we go. Okay. Miss hasn't had her Starbucks in today, so bear with me. Okay, so you must be at least 16 years of age. So that means if you're 14 or 15, you can't get it. However, if you are bigger than 16, yay, so if your age is this way, you can have a driver's license. At 16, you are able to get your driver's license. So that means the age of 16 is included. So because it's included, we will make our boundary point at 16, and we will make it colored in. What, Sion? Okay, Sion's here working in the background. So if you hear somebody interrupting, it's Sion. So take all your issues up with her. She's making faces at me now. Okay. Okay, we're going to represent this algebraically. And so we have 16 as our boundary point. And we said that any age bigger than 16. So let A represent, let's say, your age. And so any age that is greater than or equal to 16 will let you get your license. Or we could flip it. We could say flip the other way. Yeah, age is greater than equal to 16. There we go. Okay, so you are going to do A and B on your own, these two review questions, so that way we can check them together tomorrow. And we're going to do these two together. So I'm going to draw number lines. You should draw number lines, and then we'll work through this. Okay, so when you make your number lines, you should be using a ruler or the magic of smartboard that makes magically straight lines, but you don't have a smartboard, so you need to use a ruler. Okay, so on the first one, we're saying that t must be greater than -5/6. So my suggestion to you is to put these into decimals. You're not going to necessarily graph them on your number line as a decimal, but at least when you see it as a decimal, you can think of, okay, what whole numbers does it fit between? And so when we take -5/6, you should realize that it is less than 1, but just a little bit less than 1. And as a decimal, it is -0.83 repeating. Okay, so it's a little bit less than -1. So it's going to be between 0 and -1. Okay, you don't have to have a ton of values on your number line. And so it's going to be somewhere between 0 and -1, right? So then I'm going to take 0 to -1, I'm going to split it up into 6s. So this is halfway would be 3 6s. And so there. So that 1 6, 2 6, 3 6, 4, 5, and then -1 would be -6 out of 6. And so this is -5 out of 6. So -5 out of 6. The inequality is equal, so we can make a closed dot, so negative 5/6, and it must be greater. So if we're talking greater value, the inequality must go to the right. Okay, so that means t can be 0, t could be +1, +2, t could be negative 3/6. Any of those values work. On the next one, h must be less than -9. So again, I'm going to have -9 on there because that's my boundary point, -8. Okay, so -9. The inequality does not include an equal sign. So that tells me that I have to have an open circle at -9, and h must be less, and so that means go to the left. Okay, we have a couple of word problems, and that's actually what Sion's here to work on. So you're going to take a look at this word problem. You are going to try to put it verbally and graphically and algebraically, and then I'm going to put up. But you're going to pause this and try it on your own first. Okay, so in this example, we need to combine some real-life situations. We need to do two inequalities because there's a lot of information going on. So we're going to show this situation about average water use. So it says average daily water use is from 327 liters to 43 liters per person. Now for me, I think the easiest way is to look at it graphically first and then put it into words, because sometimes the words kind of can be a tricky part. So I'm going to start at 327 liters. That's my one, because it says from this to this. So I'm going to start from 327 to 343. So that means water use is somewhere between these values. If you're working in if you're using something that's colored, so a pencil crayon or something on your notes, you can do your line right on the number line. But if you're working in pencil, I like you to draw it up and over, because sometimes I can't see your pencil lines on top of the number line. Okay, so the water use is between those two endpoints. It doesn't tell us if it includes those two values, so let's leave them as open circle boundary points. So verbally, we could say water use is greater than 327 liters and less than 343 liters. Okay? So then algebraically, again, we have two endpoints, so that means our variable needs to go in the middle. So I'm going to use W to represent water used, and so W needs to be in the middle of our two boundary points, 327 and 343, and the dots are open, so there's just less than signs. So 327 is less than the water usage, which has to be less than 343. Oh, I'm going to put water used in liters. Okay, last example. So it says the most extreme change in temperature in Canada took place in January in 1962 in Prince Creek, Alberta. A warm, dry wind, Chinooks, we know what these are, took the temperature from -19 degrees Celsius to +22 degrees Celsius in 1 hour. That's ridiculous. So we're going to represent this using inequalities, and your number line for your inequality doesn't always have to be a left to right number line. If you are more comfortable with temperatures on a vertical number line, like a thermometer, you could draw that as well. So I'm going to pull up my tool and draw my number line, and you're going to use your ruler. Okay, so there's my number line for my thermometer, and really the only temperatures that are important to add on are 0, and then +22, and -19. Okay. So we're going to represent it verbally, graphically, algebraically. So again, I like to do graphically first. So the temperature started at -19 and went to +22. We're going to include those temperatures because it would have had to actually get to those temperature values for it to be included. Okay, so again, remember either the line is on or just off to the side if you're using pencil. So that's graphically. That means the temperature needed to be anywhere between those values. That's where it started at negative 19. It had to go up every other value in between to get to positive 22. So we could say the temperature was greater than or equal to negative 19, and then less than or equal to plus 22 degrees. And then lastly, we need to write it as an inequality. So temperature's in the middle. Negative 19 is on one side, positive 22 is on the other. Our boundary points are closed, so that means it must be equal. And remember, we keep our inequality signs pointing the same way. So that's kind of 3 ways. Bonus points if you can tell me how many degrees that change was. Okay, that's the end for this one. I'm going to go help Zion so that way she can destroy her Chapter 8 test later today. Everybody's name